Today you will be able to solve systems of equations using substitution. I have this list of steps that we're going to use. Please write this down. That way you can have something to fall back on whenever you go to do your assignment. So the very first step talks about solve for a variable in one equation. Now for today's practice, I'm going to provide you with that step already done. Tomorrow you'll be working with it where you have to do that. Didn't want to overwhelm you, so we're going to start with this first piece. Once you have a variable, one equation with a variable by itself, this is what I'm asking for in that first step. What you're going to do is plug that equation into the other equation. Now, what I mean by that is we know that y is equal to 3x, so I'm able to take this 3x and just plug it in where that y is. So rewriting this, we have 4x plus 2y, and that y is represented by a 3x. All right, and then we're going to have that equal to negative 30. We then go ahead and start doing some simplifying on the left side, where we have 4x plus 6x, right? We distribute or multiply that 2 times the 3, and that ends up giving us negative 30. And now you're back to your old solving equations, right? You just collect your like terms. This is 10x equal to negative 30, and then you'll divide by 10. You're left with x is equal to negative 3. I'm going to go ahead and put this over here off to the side. That'll be my x value of the ordered pair where the two systems will intersect. All right, so we solve the equation. Once you've solved the equation, after you plugged it in, of course, you're going to plug that value into the original equation. It actually says into an original equation. You can plug it into either one, and it'll work out just fine. So let's go ahead and take a look at what we're doing there. So it says take one of your equations. I'll take the first one. Y equals 3x. And my x, I've already determined, is negative 3. Right? And every time you do a substitution, you really need to put those parentheses. So you end up with, let's see, y equals 3 times negative 3, negative 9. Whew, that wasn't too bad. But I want to go back to this idea where you can plug it into either equation. You know, ideally, we want to end up with the same thing. So what if I had said, just looking at the other equation, 4x, oh, not x, right? We know what that x is. We know it is a negative 3. So 4 times negative 3 plus 2y equals negative 30. Do your math before you solve for y. That's negative 12 plus 2y equals negative 30. We'll have to add 12 to both sides to cancel this out. Plus 12. We're left with 2y equals negative 18. Divide by 2. Y equals negative 9. Notice in both cases, this one and that one, we end up with y is equal to negative 9. So there's your ordered pair. We solve for the other variable. You write these as an ordered pair, just as I've done over here on the side. That is your answer. But there's a way you can check your answer to make sure it is accurate. And to do so, I'm going to box off a little section here. To do so, what you do is plug in these answers, negative 3 and negative 9, into each of the equations to see if it actually works out. So plugging it into the top where you have y equals 3x. Well, if y is negative 9, does that equal 3 times my x value of negative 3? Yes, it does. Looking at the other equation where it has 4x plus 2y equals negative 30. Well, 4 times x, we say x is negative 3. plus 2 times y, and we say y is negative 9. Does that equal negative 30? Well, doing your math, you end up with negative 12 plus negative 18. Does that equal negative 30? Actually, it does. So this is one of those cool algebra problems where you can actually check your work when you're done to know if you're accurate or not. All right, so let's take a look at another one. Actually, I want you to try to work your way through this one. Remember, I already have the first step done for you where I have a variable by itself, right? Solve for a variable in one equation. I have x by itself, you're set. All right, next you're going to plug that equation into the other equation. So where we have this x equals negative y minus 1, we're going to take that x, right, the value that it says x is, and we're going to replace the x up there. So my new equation will be 2, plugging in that value there, negative y minus 1. Right? Notice I'm putting parentheses to show where I'm doing the substitution. And then we have this minus y still outside of that x, right? So minus y. All that is equal to 7. Right? Now you have to do some distribution and just kind of start working on to solve the equation. So 2 times negative y would be a negative 2y. 2 times the negative 1 would give you a negative 2. This minus y is out here all by itself, equals 7. Then we're going to collect our like terms. Negative 2y minus y, negative 3y, and then minus 2 equals 7. And then it's just a matter of solving for y now. Add 2 to both sides. Negative 3y equals 9. Y will equal to negative 3. All right, so I'm going to kind of set up my little ordered pair here where I got y to be equal to negative 3. All right, now we're going to take that value and plug that value into an original equation. Now, I like to choose the one that's easiest to solve, and that's what I'm going to do here. So I know x, I'm going to pick the bottom one, x is equal to negative y. Remember, you always put parentheses so you know what you're substituting in there. Negative y, and y is a negative 3 minus 1. So paying close attention to those signs there, a negative makes that into a positive. So that's a positive 3 minus 1. That means x would be equal to 2. All right, so you've solved for the variable. Write the answer as an ordered pair. I already have that over there. Now check your answer by plugging in the ordered pair. I want you to go ahead and pause and try to check your own answer here. All right, remember to check your answer, what you'll do is plug in your x and y value that you found into each one of the equations. And both equations should come out to be true statements. So for the first equation, let's do it over here. 2 times x, where x is 2, according to what we found, minus y, y is a negative 3, equals 7. So you end up with 4 minus a negative plus 3 equals 7. That is a true statement. Now let's check the other one where we had x equals a negative y minus 1, right? X equals a negative y minus 1. Well, my x value is 2. Does that equal a negative 3 minus 1? A double negative makes that a positive 3 minus 1, and 2 does equal 2. Check. All right, so if you haven't done so yet, you really need to write down this list. Copy this down in your notes, your journal, somewhere so you have it handy until you got it memorized. Also, the other thing you should really do for today's assignment is get some paper out, your pencil, and really just you're going to go through paper for this part of the course. Just kind of work these out. I know you're good with doing it in your head, but you're better when you do it on paper, and you deserve your best.